Greetings of the day, dear students. In this video, we are going to discuss the another type of filter, that is the L section filter. So, if you have watched the previous videos, as we discussed earlier, four types of filters we are going to cover. One is the inductor filter, capacitor filter, L section filter, and pi section filter. And also, we have discussed earlier the main purpose of the filter is to filter out the AC or ripple content present in the rectified output, as the rectifier which converts the AC into DC, you may not get the pure DC in the first attempt itself. So some ripple contents or AC component, what are the things present, those are to be filtered out. Now if we observe the previous discussion, the in inductor filter, inductor is connected in series to the load or in series with the load resistance RL, whereas in capacitor filter, capacitor is connected in parallel to the load resistor RL. Now in this L section filter, it is going to consist of both inductor and capacitor, where the choke L inductor will be connected in series with the rectifier and the capacitor is to be connected in parallel or across the load. This is the very important point. So this inductor is connected in series with the load and this capacitor is in series with the rectifier, and this capacitor is connected in parallel across the load. This inductor is in series with the rectifier output and capacitor is in parallel with the load resistor RL. And from our previous basics, inductor does not allow sudden changes in the current and the capacitor does not allow sudden changes in the voltage. And also uh, this capacitor is going to filter out most of the AC component. It offers high resistance to the AC component present, and after filtering that AC component, if still any AC component is present, for that AC component or ripples, this capacitor is going to offer very low resistance path or low impedance. Because of that, if still any further AC component is present, right, that will be filtered off through this capacitor, capacitor. Sometimes what happens is you can use such kind of LC sections. This is one LC section. If you want to get a smooth DC waveform, for smoothing action we can use number of such kind of LC sections. We can use several identical sections can be connected to improve the smoothing action, right? Now here, as we discussed earlier, the choke will allow the DC to pass through, but it opposes the AC, and if any fluctuations that remain in the current even after passing through the choke will be bypassed through the shunt capacitor. Here, uh, for example, only inductor or only capacitor filters are not suitable for the high-end purpose, and also the number of ripples can be reduced to the great amount by making the value of XL greater than XC at the ripple frequency value. If the value of XL is made greater than XC, so it can reduce the ripple content to the greater extent, right? But the drawback is, because of the huge size of the inductor, the cost will be more. And nowadays IC integrated circuit based IC based voltage regulators are being commonly used along with the active filters, right? So IC voltage regulators are being commonly used with active filters. And also one previous basic is, inductor does not allow the sudden changes in current and the capacitor does not allow the sudden changes in voltage, and inductor is going to offer low resistance to the DC component and the capacitor is going to offer low impedance to the AC component. That is the reason why, first of all, we will filter out, we will block the AC component by connecting this inductor or choke in series with the rectifier, right? Rectified output across the output of the rectifier, and if any further AC component is present, that will be bypassed through this capacitor, which offers the low resistance or low impedance to the low impedance to the AC component. So this is how the output we can observe. We used to get the output like this. This is the output: charges, discharges, charges, discharges, and at some we can take its average value like this. We may get the output. So this is without filter, before filtering the output, and this is after filtering the output with the L section filter, right? Thank you.